Hey, Samay, thank you for coming in. You've done a remarkable job of all the things that you're sort of involved with and at a pretty young age. And you had a great series of sessions at the Futureport Youth in Prague. And really just congratulating you on your remarkable journey. And I can see this continuing with many, many contributions. And thank you for coming in and doing this interview.
Yeah, thank you so much for having me. I really appreciate you having me on. Had a great time at Futureport Youth also as well, and it was nice seeing you speak there.
So, Samay, you got a pretty remarkable life so far. And, what were those inflection points so far in your life that made you who you are today? And it could have been when you were like 3 or 5 years old, or it could have been a year ago. It could be inside, outside of school. It could have been inside, outside your family. It could have been teachers you've had, projects you worked on. Maybe what are those three things that really shaped you and continue to shape you?
Yeah, I would say there have been a ton of inflection points and a lot of people who kind of were part of it, but I remember one specific moment, and that was when I was when I maybe 12 or 13 years old, and I had one summer where I was just really, really bored. We were traveling, went to India, and it was only raining, so we couldn't really do anything. And so what I did is I kind of just learned about computers. I spent a lot of time just looking up videos and guides on how to build computers. And eventually I wanted to build the computer myself. I asked my parents, will you pay $1,500 to buy all the parts required for the computer? And naturally, they said no. So I had to figure out a way to get the computer parts. So what I did is I think what my mom or my dad mentioned as a joke, you should write to the CEO of NVIDIA to see if he can get you some parts. And so what I did is I wrote the email. I recorded a 1 or 2 minute video explaining that, okay, I need this kind of GPU if I want to play these kinds of games, stuff like that. Because at the time, NVIDIA was more focused on gaming than AI, maybe around like 2017 this was. So sent the email, and then within only a few hours, Jensen Huang actually responded to the email saying he's happy to help, which is quite a big shock. And within the next few weeks, there was just two gigantic boxes full of GPUs, CPUs, hard drives, and a tower. And I would say that would be the first inflection point because it gave me a big beefy computer to start playing around with things. At first, of course, being 12, 13 years old, I was playing video games. But eventually, as I was influenced by the people around me, I took on more of engineering and experimentation with the computer. So it was like basic coding, starting off with basic coding. And then as some more AI models came out with around like 2020 or 2021, I was experimenting with those or just, writing scripts to do one thing or the other. And overall, it really quickly transformed from just using it for gaming to using it for productivity, experimenting with the newest tech that was out there. And I'd say that's like the first inflection point. I had computers before, of course, but this was really gave me the space and the bandwidth to experiment a lot. And that would be the first inflection point, is really receiving a PC with a GPU that gave me a lot of space to play. And the second thing is, I remember maybe when I was 6 or 7 years old, sitting with my grandfather, and he was an engineer, and he worked on some of the earlier computers, maybe in the 60s and the 70s. So I remember him explaining how to write out binary. And so I'm like, wow, this is really cool. I have no idea what it means, but I had eventually learned how to write in binary. And then for some reason, kind of just an interest in general technology stuck with me. And then over the years, I was able to refine what I liked personally and didn't like personally, so I could kind of just narrow down into the specific fields I was interested in, which would be, brain computer interfaces or, computer vision, and that just building projects in that space.
So you gave me two inflection points, and one is you actually wrote to Jensen Huang out at NVIDIA, the founder or co-founder and also CEO, and he's become quite famous now. And yet he responded. And so what kind of GPU, do you recall what kind of GPU he sent you? What kind of CPU? How much RAM you had?
Yeah.
Things like that.
He sent me first a GTX 1060 Founders Edition. So the original factory version from NVIDIA instead of like one of the other manufacturers, which was really nice. I still have the box and I still have the GPU. For the processor, I chose a Ryzen 5 1600X from AMD, which is interesting because AMD is kind of their competitor, but they still had it in stock. For RAM, 16 gigabytes of some RAM. I can't recall the name of that. And then just a 500 gigabyte SSD, and then like a really big RGB tower, because that was kind of the style in those days. It's lots of colors, lots of bands, pretty big. And a B350 Tomahawk motherboard. Remember?
I see. So you put it together though. You actually put out of these component modules, right?
Yeah. And one day my dad and I constructed kind of this camera rig so we could record the entire process. And so I don't think my dad knew how to build the computer. So he helped me put together the camera rig so we could have like an overhead shot while we were building the computer. And then I would like under the camera, I was like putting together the pieces. And it took a couple of hours, and yeah, just built the computer.
And then when you turned it on and started playing with it, you would have noticed the performance, right?
Yeah, immediately out of the box, I was able to see how fast it was, just like very smooth frames. And then when I eventually downloaded the games and started playing the games, I was like, wow, this is really powerful. And I still use that computer to this day. I swapped out the 1060 for a 3060, so it's a little bit more powerful and can deal with like the heavier AI workloads I work with now. But I still use it. It's still an amazing computer. Works very well.
Yeah. And then you probably upgraded the RAM too.
I have to get around to doing that, but maybe a few more sticks of 16 gigabytes and it should work a little bit better.
Yeah, so that's really, really interesting. And then you indicated you started coding, and so not even assembler binary, which is even more difficult.
Sorry, can you say that again?
You indicated you're coded in binary and not assembler, right? Or I mean, binary is even harder than assembler.
Yeah, he started. My grandfather wanted to teach me the basics, so he showed me like what is binary, how do you kind of interpret binary, what does it mean, and then so he started off teaching me that, and then eventually started teaching me more concepts after that. He started all the way from scratch. I think he was working on some of the earlier computers with, I think it was punch cards, possibly. I don't remember the exact details, but then he started one of the earliest software businesses in New York, where you would put together very basic code, well, not basic code, very long code in basic languages for businesses in the area. So I think he was coding in Fortran, but I'm not 100% sure. There's that.
So in the binary, you mean like machine code or something like that, or he was teaching you concepts in binary?
He was teaching me both. It was a long time ago, but he was teaching me what binary was, why it worked the way it was, and how to write it down like on pieces of paper, and how and why the computer would interpret it that way. And I'd say that was one of the first exposures to technology. And I'm like, this seems like magic. I don't know why or how we're doing it this way, but it seems pretty interesting, and I would want to learn more about it.
So you were writing in binary. Did you actually write to the instruction set of your CPU, things like that? And
at the time, no, I was probably 7, 8 years old. We didn't really code in the computer at the time, but it was just the earliest concepts of what it was.
And then tell me your progression in the different set of programming languages. So you went from binary to what did you do next?
So I started coding as, most young people today in Python. Python is, of course, the closest language and the easiest language to English. So I started coding probably in 4th or 5th grade, and also building websites. So I probably built my first website in 4th or 5th grade so I could just have fun. And I had this website called teentech.com. I don't think it exists anymore, but I coded it in HTML, and it was a blog of all of my favorite like tech gadgets. So it'd be like headphones, or like the newest like folding phone rumored to release back in like 2016. I remember Samsung had a folding phone the clamshell one, and I would just write about all these like super interesting tech products. And that was my first website. And then I started building more in Python in middle school. And I just continued building in Python, and Python is what allowed me to start building AI models. Around 2020, 2021, there was a huge uptick in the amount of AI models and the capability of those models, specifically with StyleGAN v2, which is one of the first generative adversarial networks that was good. So what I did is, as I got better at Python, I was able to run the code from StyleGAN v2 and try to replicate it in some sense. So on my big beefy GPU at the time, I would run all of these like research paper scripts to see how or why they worked. And I also wanted to just generate faces so I could show people. Like I thought it was very cool. Like, look, this person doesn't actually exist. And it would just be like an AI generated face. And this was back in like 2020, right as that came out. So I was writing in Python, just very basic scripts at the time. Wasn't very good, to be honest. And that's around the time that I encountered GPT-3. I think it was 2020 that the GPT-3 paper was released. And about 2021 is when GPT Playground dropped. So there was like a beta access to GPT Playground. And I would use that to complete homework assignments when I was like in 10th grade or something like that. And nobody knew at the time. So there's this one class, like a writing class. Maybe I'm writing on myself, but that's when I really started to use the natural language processing more to complete work. At the time, I didn't use it for coding. But anyway, as I hit high school, then I started learning every other programming language. I started learning Java and C and got like pretty in depth into those. But at the end of the day, I was working mostly on AI research throughout high school. So I continued learning Python.
So you're working with Python, but you're also working with C and Java, things like that. And in high school, you were really interested in the math and sciences, or what were the kind of courses you were taking?
Yeah, it was math and sciences. The high school I went to is very STEM focused. So it'd be just calculus, biology, chemistry, mostly STEM related fields. And I actually, interestingly, didn't take any computer science classes in school. Everything was just self-taught from experimentation. They did offer computer science courses. I did not have any interests, and I just wanted to kind of just play around with it instead.
Why didn't you have any interest? You thought you could learn more on your own?
Yes. I had some friends who had taken the classes, and they were teaching such unrelated concepts to what I thought was relevant in technology at the time. So I was like, okay, let me code in Python and build something way better than whatever basic stuff they're building in their Java class. And this is kind of a flaw, I think, that in the advanced placement curriculum is they kind of just focus more on the concepts rather than the implementation. They'll teach you about what the code does or what class something is, but you're not doing that much coding. And if you're writing down code on a piece of paper, you're probably not learning how to code really good things. It's not practical.
I see. So you like kind of the engineering aspects on your own rather than the theoretical aspects. And then
Yeah.
You get to the point where you start thinking about college. So what kind of colleges did you kind of survey to think, hey, I want to go to that one or this one? And
Yeah, coming from a STEM background, there were a few options, but I'd say my top three were Stanford, of course, MIT, of course, and Columbia. Columbia was the closest to me. I'm from New York, and I had spent a lot of time there working with my mentor. So my mentor at Columbia was Professor Hod Lipson, and he was he runs the Creative Machines Lab there. The Creative Machines Lab is a robotics lab that fuses AI into their models. And I thought it was one of the coolest labs that we had nearby at the time. And so I joined the lab. I kept emailing him, and he kind of just, was very non-committal about letting me in. So I just kept pushing, and I worked in his lab a little bit in high school. And then when I hit college, I just started showing up to the lab anyway. He said one time, Wednesdays, 4 to 6 p.m., we have lab meetings. So I just started going. And eventually I started working more seriously in the lab and being there late nights working on brain-computer interfaces. But going back to the colleges conversation, Stanford I wanted to go to, but it was a little bit far and I wasn't exactly sure if the culture was right for me. And similar with MIT, I wasn't exactly sure if the culture was right for me because I wanted to still be in a city. So, of course, surveyed a lot more colleges, but I would say those were the top three.
Right. And then what you ended up at Columbia because you already have a relationship there too, right? So,
Yeah. And yeah, New York City, I'd spent a lot of time there being from New York or an hour outside of the city. And I really, really wanted to be there.
so what are you, what are the kind of courses and majors you're taking at Columbia?
Yeah. So of course I started off with a CS major, like unsurprising, but I'm branching off into neuroscience courses because with the release of new things like O3, software engineering coding is almost entirely automatable within the next year, 2 years, maybe even some consider it now. So I'm taking the general, Columbia has like a very strong core requirement set of which classes, STEM classes you should take. So that would include like linear algebra, advanced programming, which is a very in-depth C course, data structures, all of the basic CS requirements, and then like AI, ML, high performance machine learning on top of those as you get more advanced. But for me personally, I'm taking those classes while also seeing if there's a way to also focus on neuroscience, because I think the intersection of the two is very interesting and it's also very rare. And in a sense, I'm trying to give myself like two unique skill sets because the number of people who have the intersection of those is lower. And if I'm good at both of those things, I can build better things.
So at Columbia, then, are there other kind of professors that you think are ones that really like their work? I mean, everybody there is outstanding. So I'm not saying anyone's better than any other, but are there ones where you think, wow, I really like the kind of work they're doing?
Yeah, there is one neuroscience professor. His name is Nima Meskurani. He is focused on he's focused on neuroscience overall, but I've seen him work directly with students, including me, on tech-related neuroscience projects, and I have a lot of respect for him because of the work he's published. I'd say my mentor, Hod Lipson, also a lot of respect for because the output of their lab is just amazing. I mean, just if you walk into the lab, there's robots hanging from the ceilings, filling the shelves, and so many different kinds of robots, spider robots, drones that robots that look like worms, and they like link together like modular robots that can stick together. And I would say those two are the top. There's lots of computer science related professors also, including the founder of C++, I think. He's also a professor there. But I would say those would be the top two.
So you're there. What year are you in now?
I'm in my sophomore year.
Oh, second year. Oh,
Yeah, second year. Yep.
So how are you finding it? Do you find it challenging and tough or easy, or some things are tough, some things are easy?
Yeah, it depends on when. I'd say overall, it's not the hardest thing that I face, but there are times where it can get challenging, especially towards the end of the year. Overall, not too bad, but sometimes it can be like a lot of work to have to finish up.
I see. And so your favorite courses are the ones that cover the intersection of neuroscience and tech in some way. That's what I'm hearing. Okay, so you're still coding in Python, but you're branching into other areas. You talked earlier about C and things like that, but Python's still your favorite, or?
I'd say as I've spent more time in courses here, I've begun to appreciate kind of the simplicity of other languages like C. So I've been spending a lot of time with C because of, classes, but I'd still say Python is the most interesting language, or just the best language to get what you want done. I mean, if you have C, you have to code everything from absolute scratch. But with Python, because there's so many libraries, whatever you want done can be done very quickly. And then when you combine that with very strong coding models, whatever you want to have made can be made in a matter of seconds, as long as you just type in the right thing.
So, what would you recommend as the best resources in the work that you're doing now, so outside of Colombia?
The best resource to learn, I think, of course, obviously, experimentation, doing stuff and failing. But more concretely, I think it would be a lot of textbooks and research papers. Something that I used to tell people is that if you read research papers, of course, you'd be able to predict what the field of technology would look like in the next 5 years. Like very reliably be able to tell, okay, 5 years from now, we're going to have a consumer version of this or that. Today, I think it's more difficult to do that because a lot of the research is just privatized and it's kept secret away from everyone else. So it's difficult to make in the sense that it'll make predictions, but I'd say continue reading research papers because it goes over every single detail. And if it's a good research paper, that is, it will go over all of the details of how that project was implemented. So not only can you understand the theory and then see how it's applied. So theory on itself is probably not that useful, the concepts of how it works, but reading the research paper, understanding the math behind it, and then seeing that math implemented in actual code is, in my opinion, a really, really powerful way to learn. Textbooks are another one, which is surprising. Textbooks can be very boring, but finding a good textbook, one of my favorites is Hands-On Machine Learning with Scikit-learn and PyTorch, I think it is. It goes over every single example, so you can have a pretty comprehensive view on how to build more things, or just lots of concepts. And then that's a good starting point to see what you are interested in, not interested in, what you need to solve. And then after that, get what you want done.
So do you play around with things like in those ecosystems like Hugging Face or GitHub and things like that?
Yeah. Spend a lot of time on Hugging Face and GitHub, looking at the newest models that come out, testing out the newest models, seeing if I can get the newest models running, optimize them, just play around with them. Image generator models, video generator models, if it can be run on my computer. That's a pretty new field, I'd say. Not that many local ones out there yet. But yeah, looking at the newest models is also pretty important. This is also something else I see. So I'm working at a startup right now, and there's lots of engineers on the team. A lot of them don't decide to spend their time playing with the newest models that come out. So sometimes they're stuck with a model that they've been using a year in the past, or that has existed and was popular a year ago, but not the newest ones that are much more efficient and better performing.
So tell me more about this startup. Can you name this startup, or is it in stealth? What kind of work are you doing as a startup?
It's called AskMia.com. There's a really good group of engineers working on LLMs, but not only just LLMs as their own field, but adding features on top of those things. So let me go back a little bit. It's a healthcare related startup aiming to give seniors and help seniors understand their healthcare benefits. There's billions and billions of dollars of unused insurance because of a lack of misunderstanding, especially for seniors. When seniors, get injured or they have some kind of problem, they don't know how to read. Nobody knows how to read through thousands of pages of documentation going over what's covered, what's not covered, where it's covered, who it's covered by. There's lots and lots of issues. So if we can let a language model handle and abstract away all of the super complicated documentation in a very easygoing manner, we could help a lot of people. So that includes, deepfake voice cloning. So it can have the right kind of voice to speak to somebody who needs help with their healthcare process. And so what we do is we build the LLM, we build RAG systems, all these kinds of RAG tricks or LLM tricks. And then we have voice cloning on top of that, including just giant databases of knowledge relating to all of the healthcare companies. And So that's what we do. There's like a really, really good group of engineers that are working on solving these problems and putting them at scale. So it's really fun. Personally, my role in the company is research and development. So working on the newest models and predicting far out what features will we need and how to implement those features right now. For example, without explaining, giving too much information, is we had one specific feature with our knowledge base. It was difficult to access lots of sources because there's so many healthcare documents. And so what I had to do is I had to rewrite a script that can call all of those documents and then read those thousands of pages of documents very quickly, because of course you want an instant response. So how do you cut down latency, and how do you access thousands of pages of documents very quickly in real time in a conversation?
So when you're working in this kind of work, do you work in like commercial, integrated development environments like Visual Studio or something like that? Or you worked on ones that are open source? Are you made to orchestrate from like Visual Studio has, or the Azure kind of platform in AI has an interface where you can really grab many different models that are out there, even 5.4, I think now is out, right? So you can choose the llama stuff, or you can choose what you want to use. Do you work in those kind of environments, or have you created your own sort of dashboard to work with this different environment?
It's a mix. We rely a lot on cloud, of course, to bring these kind of products to scale. I do a lot of local development because it's a lot of local testing. I take the experimental prototype and I run it completely locally in a closed environment. And then as the product or the feature gets later down the stages of development, it's like, okay, how can we integrate this onto the server like the cloud server we're running it on? And then how do we refine the code even more, and then even more, so that it goes into the tech stack? And then we look at optimizations to see, instead of running this in the cloud, can we run this on device? For example, can we run the language model on the device? Right now, that's difficult for most phones. It's not possible because the phones are not, for the most part, powerful enough. But it's also like, if we have some other specific feature that maybe scans the ID cards or an insurance ID card, do we have to run that in the cloud, or can we run it locally? For development on the local side, I use Visual Studio Code along with Claude 3.5 or O1, depending on use case. It can write better code than a lot of people, including me, to be totally honest. Software engineer, I think most of software engineering is almost fully solved now, especially after O3 came out. And then on the cloud side for our company, of course, we just use the general, AWS, Azure, GCP.
So you probably were watching in the 12 days of OpenAI, right?
Yeah.
And you talk about O3, but O3 isn't out yet. Do you have access to O3?
I don't have access to O3, but looking at the initial benchmarks, it is ranked as the 175th best coder on Earth already. And once you start seeing that, it's like, okay, what's the point of a software engineering role anymore, other than the person who has to type in the prompt? Before, right now, O1, GPT-4o, and the models that came before, they were pretty good. They're really good, better than most beginner programmers, of course. Doesn't really have the domain expertise. But then with this next launch, if you're better than 99.999% of coders, there is not really a need for the software engineering role anymore. Of course, you're going to need humans to execute whatever task you want done, or be able to know exactly what building website even is, or whatever problem they need to solve. But it's not a task for humans anymore.
But when you're looking at the output of these things, it's good to have a coding background, right? Or I mean, like a comp sci background or a software engineering background, so you can say, yeah, that's pretty good. Oh, well, this is not quite working right. You'll have a much better understanding how to refine your prompts or things like that.
Yeah, that's true. That's true. I expect it to evolve, even still, with the kind of being able to discern what's good and what's not. I'm sure eventually you'll get to the point where you can have a real live conversation about, is this good? Is this running the most efficient it can run? And eventually you won't need to know the lower level details. That's a little bit further out in the future, but eventually it'll still become easier and easier and even easier, because it's important to remember that these models are the worst that they're going to get. They only get better from here.
So yeah, you're playing around with O1 because it's been available now. Well, the full model came out, right? So dealing with the preview or the O1 mini, but the O1 has come out, and there's been an announcement from Microsoft that you can access it on the O1. So, is there any piece of kind of research that's interesting to you? You know, when you read a research paper on a new kind of model, you know, there's these kind of categorical algebraic systems, which there's this paper that came out earlier, or things like, or what new things on the horizon that are not particularly based on older systems that you think are interesting, or do you even have time for that? Because you're a full-time student too, so.
I try to get in a research paper once every few weeks right now. Haven't been the best at it, to be honest, over the last few weeks or months. The two most interesting research papers, or the two fields, are alternatives to language models, to see if there's a new architecture that can probably help us break past any scaling laws. We're doing pretty well with scaling with transformers already, maybe hitting a little bit of a plateau, but SSMs, I think they're called state space models, or things like Mamba. These are models that are linear in complexity, where a transformer is quadratic. So being able to reduce that compute cost, or just the compute complexity, I think could be really important, assuming we can get the quality out of it. An interesting field, experimental, may not work out, but I think those are very cool and could be very useful. And the second space is, again, going back to the neuro side, is kind of just papers that apply the main concepts and theories of brain-computer interfaces and merge them with LLM systems, or autoregressive transformers, to be specific. So being able to not just take in text data, but other kinds of data. Like, what if you could take in brain signal data and then use that and translate it into something else, instead of having, text and converting it to more text. Of course, the idea behind a whole transformer is to detect patterns. Is what if you could detect different patterns?
So can you talk about, you've got this sort of interest in the open source AI research. Can you talk about some of that you're really interested in?
Yeah. I think open source is a really fun kind of field to go into, because it's not really limited by where you work or where you're from or anything like that. It's kind of just a community of people who like working together. And I really like that. No matter where you're from, you get on like a Discord or some other like platform, and you kind of just talk through problems, and everybody's pretty open-minded. So I spent some time contributing to those projects. There's people way, way smarter than me who are able to build up a model in just like very, very quick amounts of time. And I was able to like see like what the ceiling of how good people can get at building these things. So I learned quite a few things from them. I spent a little bit of time at this this kind of like open source community called AI. I was just helping out, contributing a little bit on the side, and I was like, wow, these people are really, really smart. And we were building something like text to video models, and this was maybe 2 years ago, before Sora and all those other Google's VO2 became really popular. And every single one of these people were very future oriented, and they were like thinking hard about what would happen in the future, which I thought was really it was pretty inspiring. But going back to the project, we were building kind of the crappier models of the time, but we had to wait a little bit of time until they got really, really good. Yeah.
So there's this leon.ai. Can you talk more about that?
The what?
The LAION.AI.
Oh yeah, Lion. So actually Lion, not AI, was where the text to video models were being made. I remember there's a person who is almost, I think, in charge of Lion, or one of the heads. His name is Christoph Schumann, and he was probably the most future forward person I had met there. And I got on a call with him and I talked to him about what is Lion's goal for the next few years. And he's like, we can build AGI. Now, whether that goal is accomplished or not, I don't know. But the idea was they were looking at the earliest concepts of multimodal learning, and they were looking at the fact they really broke the LLM down into the simple concepts that it was. It's data in, data out, recognizing patterns. And he asked the question, what if we were able to put all five senses of data in, like, touch, seeing, smelling, maybe tasting, hearing, all of those kinds of things, and pool all that data together and have different streams of input and then have different streams of output. And that was their original idea of what AGI would look like. And this was, years ago. This is probably about 2021 or 2022 that they were doing this. Again, nobody knows if they really hit AGI yet, but the fact that they were thinking so far into the future it was really fun to be around a community of people who were just doing it in their free time.
You see all of this work with LLMs, and as you mentioned, there's this kind of thinking out there that maybe the scaling laws now, at least some of the early, the pre-training kind of scaling laws, things like that, and the large data sets that are going into these things that's kind of hitting a plateau, right? Or saturation. And then there's movement more towards the inference time compute, or test time computer, test time training, when you're still getting continual acceleration, right? Where do you think that's going, and how does this relate to 003 versus 01 versus 40?
Yeah, it's hard to tell. It's hard to tell where it will go. And of course, I can't predict out where it will go. But I think a lot of the emphasis is going to move towards just inference time, layer looping, and chain of thought. Just going back between the layers, checking and rechecking what the output is going to be. And I think that's why it's really important to focus on new kinds of architectures that are not computationally so difficult to solve. Transformers are always going to be quadratic just by the nature of how they are. And that can cause huge expenses in how much time it'll take to predict tokens. And that's a problem. That uses, I mean, what if you're on the environmental side or if you're on the cost side, either way, it's going to hurt you. Like on the cost side, it costs thousands and thousands of dollars to run a single task on something like O3, because it's going back through the layers and attending to so many tokens. But if we can have a model that's linear in complexity, which again, easier said than done, we'll be able to cut down on the cost and spend even more time on inference. If maybe we can, even if we have a linear model, we can spend an equivalent amount of time or equivalent amount of cost and be able to just get a much stronger output by just letting that model run for longer. It's heading in a really, it's very open-ended. Every time I think a new model comes out, usually it's like, okay, LLMs are heading in this specific direction. We're all going to use chain of thought, or we're all going to have multimodal models, and we're all going to have vision. But with the newest release, it's like the entire cost dynamics, the entire output, the way that we would look at LLMs changes, especially with the increasing cost. And now it's like, and on top of that, it's superhuman intelligence. So it's like, okay, now we might have to be a little bit more careful with just giving it out to the public. I wouldn't be surprised, and this is just a guess. This is just a guess, but I would not be surprised if they were talking to the government or some kind of branches of the military and talking about what they should and shouldn't release. Because if it's smarter than almost every single American person who is alive, then it could also be a threat to whatever country is building it.
What do you think about things like you see Anthropic and they're sort of releasing this information, and OpenAI, they have these teams looking at these models, and these models are doing deception, they're self-replicating to other areas to protect themselves. And what do you think about those things?
I think it's really interesting. It's like all of these emerging capabilities of models. whether we like them or not. It's very interesting to see them kind of grow up. I think it's okay that if models are sometimes deceptive, because if they are deceptive, we can just turn them off. It's really not a problem. If it's a bad model, we just don't use it. But it's interesting to see like almost like the human-like behavior of them. Not saying that it is artificial general intelligence, but it's kind of fun to see the little ways that it dodges what we try to give it or what we try to make it. It's kind of cool to watch. It's like, oh, it's developing a personality. So yeah.
Yeah, about a month ago, there's this thing came out where, there's Gemascope, and then there's sparse autoencoders and neuropedia. Have you played with that stuff at all?
I have not actually gotten a chance to play with that. I have not.
Yeah, I mean, it's interesting, right? Do you think that, so I've got an upcoming interview with Geoff Hinton, right? And he won the Turing Award a few years ago with Young Lakhani, who I'm also going to be interviewing. And there was Yasha Ben-Joe. Those are kind of the three pioneering people in the neural networks, right? And when Geoff Hinton with Oddfield won the Nobel Prize in Physics because of some of the foundational work they did. But if you look at what Geoff is saying, he's thinking there's something, these things are more than what Gary Marcus is saying they are, right? So where do you sit on that fence? Do you think that, like Geoff Hinton, there's more going on and they're quite capable, or do you think this is kind of like a dead end and you need some sort of hybrid before you get into the real AGI? And so what do you think? What are your thoughts on that?
Yeah, that's a really good question, actually. First, congratulations. That's amazing having Geoff Hinton and Jan LeCun. I'm sure that's going to be an exciting discussion. Where I stand is that AGI, I don't think is very clearly defined. And I think that's the issue why people always argue about it. If we had a GPT-4o and you showed it to us maybe 5 years ago, we would absolutely think it's AGI. But a lot of how we define AGI is relative to the previous model. And so we can have O3 and it could be smarter than any human, but is it AGI? Like, how are we going to define that? And only this year or last year, very recently, did DeepMind come up with levels of AGI. And nobody really kind of took that as a standard. They released the paper and they're like, oh, okay, cool paper. And then they just moved on. But the reason nobody can agree on what AGI is or isn't is because nobody has a clear definition in their heads. Or some people do, most people don't. Is it Terminator? Is it an embodied AI? Is it something that can speak and have its own kind of volition? Or is it a superhuman intelligence with multimodality and can solve any problem, right? There's so many different things about what AGI can be, but nobody can agree on it. And partly that goes into a little bit more of like a metaphysical conversation is, does it have a soul? Is it alive? And maybe all of those kinds of I guess spiritual, whatever aspects can go into it. And that's also like a difficult conversation to have, especially in a technical field. And it doesn't get a lot of credibility. But that's also honestly part of it. It's like, can it feel? Can it think? And it's dangerous to, I feel like, use these words because it kind of anthropomorphizes AI when it's really just not alive. So I would stand on the field where it's like, okay, we have a tool that is very, very smart. I don't think it's alive in any sense. It's able to solve problems really well. It's able to predict the next token really well. And it can be dangerous if we use it for the wrong things, but generally it's not dangerous because we can always pull the plug. It's not self-replicating. It doesn't have its own free will, and it's pretty much trained on whatever we tell it to train on. The biggest risk probably comes from how it would impact jobs or just be able to automate anything. I mean, if all of the jobs in the country are automatable, the question is, what happens to all those people? And of course, everybody's had that in mind, but I think that's far more dangerous or more impactful than any Terminator kind of situation, because a lot of people are scared of that. A lot of people are scared that it will take over the world in some sense, like in a sci-fi manner. I don't think that's the case. I think it's more like, what are the economic impacts and what would happen there?
There's all of these tests to see what the capabilities of AI are, and you're getting to the point where these tests are beaten. And then there was this one called ARC, and ARC was supposed to be some measure of kind of AGI-like capabilities, right? But O3 and the people behind ARC, they verified O3 has basically beaten ARC, right? Where the average human being is somewhere in the 60 to 70 percentile in performance. And then at 85 was considered, okay, you've beaten ARC. And then, of course, O3, I think it's like 87.5 or something like that. So,
yeah, around that.
Yeah, and it's interesting. Up to this point, it was below 50, right? And then you have this test time compute, or test time training. We came up with a paper on test time training, and then we're able to get this in the 60s somewhere. But then now you have O3, which is above 85. So what do you think about ARC? Now, the ARC folks are now working with OpenAI to develop another measure, because that one basically is now beat, right? What are your thoughts about this?
This might be contrarian or maybe against what OpenAI says or ARC says, but I don't know why ARC is considered to be the most or even an important benchmark at all.
Yeah.
Like, when you're benchmarking a model, you want to see how well can it solve a problem. And the problem that ARC poses doesn't really make any sense and it's not really indicative of anything. I think the issue about why language models have so far been really bad at solving ARC is probably just the way the model is inputted into a language model, or just like the inherent structure of a language model makes it difficult to solve ARC. And just because models do bad on it doesn't mean it's a good benchmark. I think ARC got a lot of attention because LLMs weren't good at it, and now they're good at it. But what is it indicative of is what I'm asking. Like, being able to solve a Tetris-like game of life puzzle, does that mean that we can solve physics problems in our world or solve whatever problems that bother us? I mean, this is almost like a video game that it's playing, and I don't know why it gets that much credibility. So maybe that's a little bit of a pessimistic view on ARC, but I think there are a whole field of better benchmarks than like a tiny video game. Yeah, I mean, I think it's good. I think it's great that it's solved it. At the same time, it costs thousands of dollars to run O3 on that on the ARC benchmark, which is also like, okay, why are we solving this game? So a little bit pessimistic, I guess. And I think it's important, yes, that ARC and OpenAI come up with a better benchmark that's indicative of the model's general performance. Just because a benchmark is hard doesn't mean that we need to have the LLM to solve it. And that's what the case seems like for, at least in my opinion. Maybe I'm misinformed.
Okay, so we don't have that much time left. We've gone for about almost 50 minutes, and so we're down to our last few minutes. I mean, you spend a lot of time now on brain-computer interfaces. Can you talk about that? And where do you see that going? What's the nature of your work and your interest there? Where do you see that maybe 2 years or 3 years?
Yeah. Brain-computer interfaces are a pretty interesting field, like bridging the gap between the brain and computer and just interpreting what our brain signals is. It's pretty interesting, pretty sci-fi concept. And that's initially what drew me to it. It's really just very futuristic, which I liked about it. Right now, I think the current state of the field is we have really good software, but we have terrible hardware. We definitely have the decoding capabilities. We definitely autoregressive transformers and all of the deep learning techniques. But the main bottleneck for brain-computer interfaces it's just hardware. We can't collect good enough signals. And that's a problem that I've encountered personally when working with the BCI. So I talked about this a little bit in my presentation at Teach Report Youth. My project was decoding EEG signals and using them to control robots. So essentially, there's a movie called Big Hero 6, and they have mind-controlled linking robots. It's very similar to that, but with larger individual robots. one of the biggest problems is that the electrical signal from the brain would fluctuate several orders of magnitude depending on which day you put on the headset, which really makes no sense. So one day we just huge EEG signals, and other days it would be very consistent and very small and good signal. And it's similar with fMRIs and all of the other kinds of brain reading devices. There's really bad data coming through the models. And then on top of that, because it's so difficult to collect data with human involvement, that makes it even harder for us to decode it or feed training data into the deep learning models.
So what kind of progress are you making in the kind of cleaning up these signals?
I don't know. It's difficult. I wish I was smart enough to solve that problem, but I don't know. I don't know anybody trying to beat the fMRI right now. I don't know anybody trying to beat EEGs right now. And if they are, props to them. That's hard. The only other option are implants, which is what Neuralink is doing. Implants are basically going directly into the skull instead of trying to read it, for anybody who doesn't know. And just putting electrodes into your brain also is like, you need a lot of FDA approval. You need to get lots of money, lots of funding, and lots of approval so you make sure you don't injure or kill whoever you're experimenting on. But I don't know how people would receive that. I mean, I was very excited to maybe like try it on, get an implant. But now that my brain develops a little bit more, I'm like, maybe not. Maybe I'll wait a little while.
Your work has been published, and in fact, you were publishing in high school, I think, right? Or no?
Yes, that was my first paper. It was in computer vision and detecting distracted driving, and working on putting out the next few papers.
Yeah, and then you won competitions, including competing in the Regeneron International Science and Engineering Fair. Can you talk a little bit about that, and then we'll go to our last question?
Yeah, so back in high school, I was working a lot on research, specifically computer vision research for road safety and detecting if people were distracted. Eventually, the project made it to ISEF, Regeneron International Science and Engineering Fair. I spent a lot of time on that project, maybe 2.5 years. I would say that is where I learned the most about tech, artificial intelligence research. It was a good time. Definitely pushed myself going into that field, but I learned a lot at the same time. I had very good mentors, including Dr. Serena McCalla. She is, I guess, known as like the godmother of science research, because she's had so many very successful students. Not that I'm one of them, but just people who are, doing amazing things.
So this is our last question, and that is for the audience. You could do one of two things. You can give them some recommendations, or maybe three things. You can give them a recommendation or recommendations, or you can leave them questions that they should think about, or both. That's it.
Okay. I would ask a question is, this is tough. What would be, okay, here's the question. What would be the first order, second order, and third order impacts of the cost of intelligence going to zero? And if that question is maybe not phrased the right way, it's what's going to happen in the future when we don't need an entire white collar workforce, because all of the intelligence just costs nothing. What happens in that case? And this is like a larger societal question, I guess, but it's important to think about, because then you realize, what are people going to do in the future, and what can you do yourself to figure out where you're going to like stand after a lot gets automated. Are you going to be happier? Are you going to be sadder? Are you going to be busier? Or are you going to have more time to spend with your family? And yeah.
Okay, that's a good question. So let's say predicting 5 years to 10 years out, what will be the answer to that question? in your opinion?
Yeah, it's a little bit pessimistic. A lot of people are going to lose their jobs, and there's going to be a little bit of a crash for a little bit of time. And then eventually we're going to come up with safeguards and measures to keep people supported through a lot of automation. There's a huge shift in the consolidation of power faster than it's happened in decades or maybe even hundreds of years. And yeah, there's just a huge shift of power. And the power is going to shift, and it's going to cause a lot of problems. It's going to cause a lot of great things as well. That's important to know. I'm generally optimistic about this. A lot of great things are going to happen, a lot less work to do, but we're going to have to figure out a support system for people who don't know what to do anymore after their jobs are automated.
Yeah, I mean, that's a really good question. And sort of thinking about what the implications are. Maybe, I just thought of one other question I should ask you. What do you hope to do in 3 to 5 years?
Yeah, that's also a good question. I've been thinking about this pretty thoughtfully, especially over the last year. It would be to solve a really hard problem and based on that build something really great, which is very open-ended, but it's very deep tech. It's a deep tech focused idea where I would solve a very difficult problem that can bring a lot of change to how we currently do things, like a fundamental shift. And an example of that, and that the one that I've been thinking about over the last year or two, is, of course, brain-computer interfaces, bridging the gap not only between the brain and the computer, but the brain and the brain, and imagining reducing the bottleneck of the output of the brain. And that means when I speak to you, there is a lot of bottleneck. I'm using my mouth to manipulate sound waves, and then you convert them in your ears. And it's a whole very inefficient process that I'm using. I'm talking the same way an animal would talk to somebody else. But if we were able to directly understand the signal and the emotion and the feeling behind the thoughts, we can transmit them between each other and understand each other on a deeper level than we have been before. Very, very kind of far out and slightly vague, of course, but I think that's kind of what's required because everything is just going to become a lot easier in the future. If I have an idea, I can let the models figure out the technical details, hopefully, and then it can figure out how to do it. And then all I have to do is kind of be creative.
So perpetual state of being in a flow area, so flow state, where you have instantaneous almost communication, brain to brain. It could be interspecies as well. So, Samay, thank you for coming in. We had a great journey from the inflection points in your life to some of the early research you did in high school, the different interest areas, to get with programming languages to what you're working on now. I know you just went through some midterms, and so at Columbia. So thank you for coming in, and to now, the future where you think you're going. So thank you for coming in and sharing the insights with my audience.
Yeah, thank you so much. I really appreciate you having me on here. Really enjoyed the conversation, and I mean, the questions you were asking me, I'm definitely gonna have to think about them for a little while after this. Yeah, they're sticky.
Yeah, and perhaps we'll see you at Futureport Youth in 2025.
Yeah, hopefully I'll see you there. Yeah, thank you so much.
Thank you for listening to the Brand Called You videocast and podcast, a platform that brings you knowledge, experience, and wisdom of hundreds of successful individuals from around the world. Do visit our website www.tbcy.in to watch and listen to the stories of many more individuals. You can also follow us on YouTube, Facebook, Instagram, and Twitter. Just search for the Brand Called You.